In the previous video, we were introduced to while loops and for loops, but why would we want to use these things? In this video, I'm going to give you guys a few examples and talk about some other things related to loops. The first thing that you might want to do is you might want to build a related list. So for example, if I have a list of numbers and I have 1, 3, 5, 10, 15, and let's say that I want to know the squares of all of these numbers and I want to put those into a list. Okay, so I can have a list squares and I could, manually do this. 1, 9, 25, 100, and 225. Okay, so I could manually do this, but what if I have some random number that I don't really know? Then it gets a little tricky, right? Or if my list is really long, then I might not want to calculate all of those squares. So what I can do is I can use a for loop in this case. So I can say for num in numbers, what I want to do is I want to calculate the square of that number, right? So I can do that by doing the double asterisk and then 2. So that means raise to the power of 2, which is a square. And then I can add that, so I can append this to my squares list. And at the very end, I'm going to print, this was my original numbers list, and then numbers. And I'm going to print, these are my squares and squares. Okay, so let's run this. And cool, we see we get our squares 1, 9, 25, 100, 225, and whatever the square of 12,497 is, which is this number right here. Let me go through this on the iPad so we can kind of visualize this. So here is my virtual computer world. Okay, so I have some variable numbers, right? And I'm setting this equal to a list. And for the sake of this example, let's ignore this, like the 10, 15, and whatever number. So numbers is just going to be a list with 1, 3, and 5 in it. So here I have 1, then 3, and then 5. Okay, and squares is kind of just going to be an empty list. Okay, so I'm just going to draw a really thin U type thing to represent that it's an empty list. It has nothing in it. Okay, basically what I'm doing, let me move squares down for the sake of this example. What I'm doing is I'm creating in this for loop, I'm creating some variable called num, and I'm pointing it towards 1. So what I'm doing in this for loop is I have some variable name, num, and I'm going to go through all the numbers in numbers. So num right now is 1, right? And what I'm doing is I'm actually creating another variable called square, and I'm setting that equal to, okay, num squared, which right now is 1. So then I want to take that 1 and I'm going to append it to squares here. So now my squares is 1 long and it has 1 in there. Okay, so now I finished everything between those two lines. So I'm going to take this num and I'm going to scoot it over to the next thing. So now num is 3. Okay, so square is not 1 anymore. Square is now 3 squared, so that's 9. And I'm going to append that to squares. So I'm going to add another square here, and I'm going to put a 9 in there. Okay, and then finally I take this num and I slide it over one more to 5. And now my square, 5 squared is 25. And I'm going to now add that to my squares list again. So 25. So at the very end, when I'm printing numbers, I get 1, 3, 5. And then when I print squares, Well, okay, what is squares? It's 1, 9, 25, right? And that's right here. So that's building a related list. So another use case is in computer science, we want to maybe iterate through all of the integers between, two numbers. So for example, if I wanted all the squares from 0 to 9, I could say, okay, for I is just, again, my variable name, in 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, I can print out I squared, right? And that would give me the square of all those numbers. Okay, cool. Now, what if I told you I want the square of all the numbers from 0 to 99? Would you come over here and do... Probably not, right? Because it's really easy to make mistakes. And remember, in computer science, we want to be as concise as possible because the less code we write, the less likely we'll actually make mistakes. In this specific case, if we accidentally make a mistake, okay, so what? We forget to print something. It's not like a huge deal. But let's say you're working with SpaceX and, you want to send a rocket to Mars. Well, that one missed digit might be a big deal. And so instead, what we can actually do is use something called a range. So if I type in this keyword range and I say like how many numbers I want to iterate over, it'll iterate from 0 and it'll go through that many numbers. So if I say for I in range 10, well, it'll do 0 and then it'll like continue counting until we've hit 10 numbers. So what is that? That would be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And how many numbers is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we've actually already iterated through 10 things, and we're going to print I squared for all of those. And you'll see that we actually end up with the exact same thing. So one thing to note about range is that if I pass in range of some number, it'll go from 0 all the way to that number minus 1. So if I do range of 100, it'll go all the way through 99, not 100, okay, 99. So the square of 99 is 9,801. Okay, so this is a lot easier than trying to write out all of those numbers. Another use case of loops might be looping over indices of a list. What does that mean? Well, okay, so if I have a list that's like, red, orange, green, and I want to go through each of these items, well, what I can do is for I in range 3, I'm going to print whatever this list is at that ith element. Okay, so basically when I is 0, I will get the first element because I'm indexing into the 0th spot. When I is 1, I get orange, and then when I is 2, I get green. Okay, so if I run this, you'll see I get print red, orange, then green. Okay, and then here I might, instead of 3, I can actually use the length of x. Because what we want to do is we want to iterate through the indices of x. And we can make fewer mistakes if we use this like built-in length estimate rather than hard coding, okay, x is 3. Because what if I come here and I add purple? Well, if we had 3 here, then we wouldn't actually get purple, right? Because it'll only iterate through the first 3 things and not the first 4. So why did I want to iterate through the indices? Well, sometimes we actually want to use that value somehow. So for example, if I wanted to print the value at index and then I, and then this is, and then whatever it is, I could do that when I have the index. But if I only iterated through x, the sequence, I would lose that information. So here I'm basically iterating through the indices 0, 1, 2, 3 of this list x. So let's print that. Okay, so the value at index 0 is red. The value at index 1, orange, 2, green, 3, purple. Okay, so sometimes I want to iterate through indices. Another example of a while loop, just because I had a couple examples of for loops, is, for example, I might have n equals 100. Okay, and while n does not equal 1, I want to divide n by 2. And maybe what we actually want to do is we want to count how many times we have to divide by 2 in order to get to n. So at first, the number of divides that we have is 0, and every single time we divide, we're going to increment this by 1. So remember that plus equals 1 is the same thing as doing num divides equals num divides plus 1. And then at the very end, we can print the total number of times it took to get to 1, and we imprint num divides there. So I'm actually going to change this 100 to 8 for this example. And let's run this. Okay, we get the total number of times it took to get to 1 is 3. Cool. So actually, what we just coded here is the log base 2 of some number n. So here, let's say n is, let's say n is 2048. Okay, if we wanted to know the log base 2 value of that, well, if we ran this, then the total number of times it took to get to 1 is 11. Okay, now something to be careful about is, oh no, what did I just do? Is this an infinite loop? I'm not getting anything over here. And the answer is yes, it is, because the condition that I have here is while n does not equal 1. So as long as it's not equal to 1, which it will not be unless n is 2 to some power, then it would never actually get to this like print statement because we're iterating here forever and ever and ever. In today's lesson, all we learned was some examples of for loops and while loops, and we just dove a little bit deeper on those. So stay tuned for the next lesson. We'll be learning about functions.